Today, we're going to talk about a problem that, let's be honest, every successful app eventually runs into. It's that moment your small, perfectly behaved system has to go out and face a massive, totally unpredictable world. We're talking about taking Kubernetes from just a pilot project to a full-on, battle-tested playbook for some seriously extreme scale.
So let's just dive right in. Picture this. You've built this amazing application. It's slick, it's reliable, and your first 100 users, they absolutely love it. But what happens when that number doesn't just grow, it explodes? Systems that feel rock solid can become a complete mess, just totally uncontrollable when you crank up the volume. This is where a great design can just fall apart and you start hitting limits you never ever knew existed.
To really get why Kubernetes is such a game changer, we first have to understand the problem it's solving. So let's take a quick step back and see how we ended up with all this complexity in the first place.
Okay, so our story starts way back in the traditional era. You had one app, you put it on one physical server. Super simple, right? But also incredibly wasteful. Then came the virtualized era, which was a huge leap forward. We could run a bunch of VMs on a single server. Much better, but each one of those VMs still had to lug around its own full operating system. And that brings us to today, the container era. Containers are super lightweight and portable because they share the host OS, which makes them crazy efficient. And, as it turns out, creates a whole new world of challenges. Yeah, all that amazing efficiency, it created a brand new headache. All of a sudden, you weren't managing a few dozen virtual machines anymore. Now you've got hundreds, maybe thousands of these little containers floating around. And if one of them goes down, another one has to pop up instantly. So how do you manage all that? How do you make sure your app never goes down? Trying to do that by hand? No way. It's impossible. You need a system. And that system, the one built from the ground up to bring order to the chaos of containers, is Kubernetes. It was literally designed to be the answer to this exact problem. And you gotta love the name, right? It tells you everything you need to know. Kubernetes comes from the Greek word for helmsman or pilot, the person steering the ship. And that's exactly what it does. It pilots your containers through the stormy seas of a production environment. It's an open source platform, originally from Google, and it's all about one thing: automation. And when we talk about automation, this is what we mean. Kubernetes is like the ultimate pilot. It handles load balancing, spreading out traffic like a seasoned captain. It manages your storage. It automates new feature rollouts. And hey, if something goes wrong, it can roll them right back. But the most magical part, for my money, is the self-healing. If a container fails, Kubernetes just replaces it, often before a human even realizes there was a problem. It's pretty incredible. So it's really, really important to get what Kubernetes is and what it isn't. It is a super powerful framework, basically a set of building blocks for running these complex systems. But it is not a complete all-in-one package. It's not going to build your code for you or give you a managed database. And that's on purpose. That's by design. It's meant to give you flexibility and choice so you can plug in the exact tools and services you actually need.
Okay, so Kubernetes is powerful. It can pilot our containers, but what happens when that little fleet of ships turns into a full-blown armada? Even a system that's designed for scale has its limits, and finding those limits, well, that's the next big challenge.
Let's talk for a second about what massive scale really truly means. To make sure Google Kubernetes Engine, or GKE, is rock solid, new releases get tested on clusters with up to 15,000 nodes. And get this, that's not a one-time thing. That happens twice a week. This is the kind of insane testing you need to do to find those little bottlenecks that only show up under huge pressure. And it's how you build real trust in the system.
Right, so running tests at that level isn't just about flipping a switch and hoping for the best. It takes a really clear strategy. So let's break down the playbook for how to actually do this. A playbook that's come from years of pushing these systems right to their breaking point.
The playbook really boils down to 3 huge things you have to do before you even start the test. First, you've got to set crystal clear goals. Second, and this is a big one, you absolutely have to optimize your costs. And third, you need to prep your infrastructure meticulously. So let's dig into each of these.
Setting goals isn't just, picking a big number. Your high-level goal needs to be tied to some real business value, like, say, doubling the number of concurrent jobs. Then you map that goal to technical resources. How much CPU, how much memory, how many nodes is that going to take? And here's the crucial part. You have to plan to test the friction points. What happens during a cluster upgrade?
Or what if an entire data center zone just goes offline? You have to simulate that real-world stress.
And now we have to talk about the elephant in the room, money. This kind of testing is not cheap, not at all. Some of these tests can run into the hundreds of thousands of dollars. That's a serious chunk of change, which makes our next step just absolutely vital.
So how in the world do you manage that cost? Well, there are a few key strategies. A common one is just making the test as short as possible. For example, Google's internal teams managed to shrink a 15-hour test down to just 3 hours without losing any of its value. But the single biggest way to save money, well, it comes down to what kind of computers you use for the test. And the impact of that choice is just staggering. By running your tests on what are called spot VMs, which are basically the cloud provider's spare capacity that they sell at a huge discount, you can save up to 91%. That's not a typo, 91%. For a massive test, that is an absolute game changer.
And finally, preparation is everything. You can't just decide to spin up 15,000 nodes out of the blue. You need to run the test in its own separate, dedicated project. You've got to request those huge resource quotas way in advance. Getting your network config right is critical, and trust me on this, you want to get your account and capacity teams involved early on. And always, always, always before the big show, do a small dry run just to make sure everything's working.
All right, so the goals are set, the costs are under control, and the infrastructure is ready to go. Now it's time for the moment of truth, running the actual test. And this is where the people become just as important as the technology.
I just love this quote because it captures the intensity of this moment perfectly. This is not some background task you just kick off and forget about. It's a high-stakes, all-hands-on-deck event. Teams will literally book a war room for the day, get all the key players in one place to watch, analyze, and react to things as they happen in real time.
So, what's the test runner actually doing in that war room? Well, first, they assemble the right team. Your DevOps folks, architects, developers. During the test, their job is to be a data sponge. Collect everything, every metric, every log, even record the conversations people are having. You have to be ready for things to get a little unstable, and you've got to be ready to find quick fixes. And here's the most important piece of advice. Expect to run the test more than once. The first run is almost never a perfect success. Its real job is to teach you what you need to fix for the next one.
And this really brings us to the core philosophy, the big idea behind all of this. We have to stop thinking of our infrastructure as just some static hardware. A cloud system is software. And just like any other piece of software, every single change, a new Kubernetes version, a tweak to the architecture, that's a new release. And it needs to be tested with the exact same discipline you would apply to your own application code.
So after going on this whole journey, from the history of deployment to the intensity of a 15,000 node war room, the question I want to leave you with is this. Is your system just working? Or is it truly ready for whatever comes next? Because building for scale isn't an accident. It's a deliberate, tested, and repeatable process.